Hey, welcome back to Mr. P. Helps with Algebra 2. This is Unit 5, Topic 1, SLT4. In this one, we're going to be finding conditional probabilities using a two-way frequency table, kind of like what we've been doing in the last two videos combined. Starting off the warm-up with two-way frequency table. So 40% of students participate in one or more athletic activities. 40% out of 100 would be 40 out of 100 or 400 out of 1,000. So that's your total amount of people who participate. So that goes down here. 58% of students are female, so 58% is 58 out of 100 or 580 out of 1,000 if you add a 0 to both those numbers. So 580, and this is 168 of the students are males and participate in athletics. So that goes right here. So that means this number is going to be 232. Then we can go, keep in mind this is going to be a 1,000 table, so we know this is going to be 420, this is going to be 600, and then we can use subtraction for the rest. So if you subtract 420 minus the 168, that's going to give us our difference. And pulling up my calculator now. Okay, need to have this ready. All right, so 420 minus 168, and that gives me 252. 580 minus 232 gives me 348, and if you add those two up, yes, they do equal 600. Okay. The probability that a randomly selected student participates in an after-school athletic program. A randomly selected student participates in athletics. That was your 400 out of 1,000, or 40%. That was given to you. Okay, so we've actually done all of these things. Use the table to calculate each of the probabilities described. The probability that a randomly selected student who is female participates, so we know it's a female. So we know it's out of 580 people, because that's what we know. Remember, this is conditional probability. It means it's not out of 1,000, it's out of just a certain amount of people. What's the probability a randomly selected female participates in an athletic program? So that would be, how many females participate? 232. And then I can change that to a percentage. Divide by 580 gives me 0.4, which is 40%. The probability that a randomly selected student who is male, okay, so we know the person's male, participates in athletics. Okay, so same things we just did a second ago. Wrong way. So males, 420, and then you would do 168 divided by 420, and that would give you your percent. Well, I'll give you a decimal, which you can then change to a percent. All right, so independent events are two events where the outcome of one event does not affect the other. So like if you flip a coin and you roll a die, the coin is not going to change the outcome of the die. They do not affect each other. If you're tossing a fair coin and it comes up heads 3 times in a row, what do you think the fourth toss will be? Well, it's going to be 50-50 chance that it's going to be heads again. Well, just because you got heads 3 times in a row does not mean you're going to get heads on the fourth time. If you're rolling 2 dice and the first roll is a 5, what's the chance of the second roll being a 5? Well, it's still 1 out of 6 because the second die is not affected by the first die. What about if you're drawing from a deck of cards and the first draw is an ace? Does that affect the probability of the second draw? Well, it depends upon whether or not you put the first card back after drawing it. So if you don't put the ace back, then this ace is gone and you only have 3 aces left. Obviously, you're going to have a less chance of pulling that ace because there's less of them. All right, so first thing to do is complete the hypothetical table. So this has to be 550. This would have to be 250. This would be 400. This is 200, and this would have to be 150. What are 2 probabilities that you need to calculate? Well, if I need to know, complete the following table. Are the events okay? So determining whether or not they are independent or not. So when you have a table like this, you need to do parallel probabilities, which would be something like this over this and this over this. And the reason why I call them parallel is because this line and this line is parallel to each other. So we need to know whether or not the probability of A occurring, so this is complement of A, has the same chance as if, I should have done the other way around. So this is B, this is not B. So the same chance whether or not B occurred or not. So if B occurred, the chance of A happening is 550 out of 800. If we don't know if B occurred, then the chance would be 600 out of 1,000. If this is the same odds as this, then we know the outcome of B did not affect anything because it has the exact same odds in this case. So the second probability has to do with given that. So we would want to know the probability of A given that B occurred is the same as the probability of A given that, probability of A given the fact that B occurred is the same thing as the probability of just A happening. Please, the second note, so this one right here is given that. Note number 1. Start with the probability first. Okay, so it really doesn't matter which one you do. Keep in mind that parallel probabilities don't have to go straight across. You can actually do like 550 out of 600 and 800 out of 1,000. Go this direction. Or you could use these numbers, this over this and this over this. One of them has to be the totals. One of them has to be total over total, and the other one is the index over a marginal number. And they have to be parallel, of course. So it doesn't matter to go this way or this way. Actually, I think there's like 8 different ways you could actually prove it. We want to prove whether or not these are independent or not, and we don't want to figure out these boxes. So one way to do it is to go 7 over 73 and see if that's equal to 35 over 365. Well, you could use a proportion, just simply cross multiply. And if this ends up being the exact same as this, then you know that this is equal to each other. 7 times, let me clear that out. 7 times 365 is 2,555. 73 times 35 is also 2,555. So these are independent events. So whether or not it's raining outside has nothing to do with whether or not she is grouchy. All right. I think I'm actually going to stop on that note. Thanks again for watching. Please give it a like to help you learn something about how to do two-way frequency tables in order to determine if they're independent events using I know it's a mouthful, using the relative probability. Thanks again for watching. Have a great day.